Dear students, the next topic in module 3 we are going to discuss in this video is Unix kernel support for process. Let me write here process. So as we know, Unix kernel support for process. The data structure and execution of processes are dependent on operating system implementation. So how a process gets executed, it depends on operating system implementation. Now Unix process consists minimally of text segment, data segment and stack segment. Every process has these three important attributes: text segment, data segment and stack segment. What is segment? A segment is an area of memory that is managed by the system as a unit. Means some part of memory is dedicated in a process. Some part of memory is dedicated for text segment. Some part is of memory is dedicated for data, and some part of memory is dedicated for stack. A what all things text segment consists? A text segment consists of the program text in machine executable instruction code format. So in the text segment, that programs text will be available. Whatever programs we write, that code part will be present in the text segment. The data segment, in the data segment contains static and global variables and their corresponding data. So in a program, we define different static and global variables, and corresponding data also we define. So that will be present in the data segment. A stack segment contains runtime variables and the return addresses of all active functions for a process. What all things will be present in the stack segment? The stack segment contains the runtime variables and return addresses of all active functions. As we know that when a function is called again and again, so the when a function is finished its one time of execution, that address will be stored in the stack. Again the function will be called. So again when the function is executed, that next address will be stored. Like when the function is called next time, the address of the previous runtime will be stored in the stack. So all these things are there. Unix kernel has a process table that keeps track of all active processes present in the system. So for example, just see, Unix has a process table which contains all the active processes running currently. Next, some of these processes belong to the kernel and are called system processes. So some of these processes belong to the kernel and they will be called kernel processes. Every entry in the process table contains pointers to the text, data and stack segment and also to U area of process. So every entry in the process table, it contains address to the text segment, data segment and stack segment. It also contains U area of the process. It also contains the U area of a process. U area of a process is an extension of process table entry and contains other process specific data such as file descriptor table, current root and working directory inode numbers and set of system imposed process limit. So in U area, that file descriptor tables, current a directory, and all those informations will be available. So here you can see that the kernel maintains a process table in which all the active processes or running processes information will be available. So a process table holds the address of per process region table and file descriptor table, current directory table, which is also called U area. In the per process region table, that kernel region table will be there, and kernel region table will hold address of the text segment, data segment, and stack segment. It means indirectly we can say that a process table contains the address of the text segment, data segment, and stack segment. So region table, here, where is the region table? Here is the region, kernel region table. So region table entry describes the attributes of the region, such as whether it contains text or data, whether it is shared or private. So it defines what all things will be stored here: text, data, text or data, or any other things, whether the data is shared or private. The extra level from the per process region table to kernel region table allows independent processes to share region. Some region are also shared here. A per process region table, it can be shared also. Now all processes in Unix system except the process that is created by the system boot code are created by fork system code. Beginning only we have been studying that in the previous slides, previous videos, so many times we studied that uh, any process can be created using the fork system call, but some beginning process which is called system processes will be started when the system get on. After the process system call, once the child process is created, both the parent and the child processes resume execution. Once the one, you can see that here in the process table, here this is a parent process, here a child process. Parent process has created a child process. Now once the child process gets created, parent process and child process both started execution. When a process is created by fork, it contains duplicate copies of text, data, and stack segment. You can see that when a child process is created, it gets a copy of text, stack segment, data segment, and text segment. Here also, child process also has stack segment, data segment, and text segment. And also it has a file descriptor table which contains reference to the same open files as the parent, such that they both share the same file pointer to each open files. So it also contains a file descriptor table which holds the address of the same file table maintained by the kernel. So this is all about the Unix kernel support for a process. This is how the Unix support for the process. So this is all about internal mechanism when a child process gets created and when it gets executed. This is how it happens. So we will wind up the topic here. Thank you very much.